Hello everyone. In the previous session, I have explained the concept of poset. Now let me explain the one of the most important concept called hash diagram. HASSE, hash diagram. Mainly hash diagram is used to represent poset. So as I already told you, given a relation R which is reflexive, antisymmetric and transitive. If it satisfies all these three conditions, we say a given relation is poset or partially ordered set. So given relation can be represented using hash diagram. Now let us take a simple example. Suppose if I have a set A with elements 2, 3, 6, 12, 24, 36. Fine. Now I have a relation given which is defined on a given set, say poset. Relation is none other than poset. Mainly hash diagram is used to represent poset. So let me take one of the poset as 2, 2, 2, 6, 2, 12, 2, 24, 2, 36, 3, 3, 3, 6, 3, 12, 3, 24, 3, 36, 6, 6, 6, 12, 6, 24, 6, 36, 12, 12, 12, 24, 12, 36, 24, 24, 36, 36. So clearly it is a poset. In the sense it satisfies reflexive, antisymmetric and transitive relation. Now we are going to represent the same using hash diagram. And the procedure is quite like abstract. Just you need to concentrate. So let me draw hash diagram for this. Let me mark a vertices right from the bottom. 2, 3, 6, 12, 24, 36. Clear? Now let me mark the relation. 2 is connected to 2. So self loop. Clear? Next 2 is connected to 6. 2 is connected to 12, 24, 36. 2 is connected to 12, 24 and 36. Next coming to 3. 3 is connected to 3. Self loop. 3 is connected to 6. 3 is connected to 6. Next 3 is connected to 12. 3 is connected to 12. Next 3 is connected to 24. Next 3 is connected to 36. Clear? Next 6 is connected to 6. So self loop for 6. Next 6 is connected to 12. Again 6 is connected to 24. So 6 is connected to 24. Next 6 is connected to 36. 6 is connected to 36. Fine. Next 12 is connected to 12. Self loop. Next 12 is connected to 24. 12 is connected to 36. Next 24 is connected to 24. Self loop. Next 36 is connected to 36. Self loop. Fine. First I have represented the given relation in a diagram representation. Now as per the procedure of hash diagram, first we have to remove all the self loops. See here, I am going to remove all the self loops. No need to write again, but you have to, while writing in exam, first step you have to write like this. See, first step, draw the digraph. Draw the digraph of R. Fine. Second step, step 2, remove all the self loop. So when you are going to remove all the self loop, you are going to get a diagram again. So instead of writing again, I am just erase here itself, just in order to consume the time. So I am going to erase all the self loops. Fine. Right now I don't have any self loop. So for the step 2, you are going to write this diagram with an arrow mark. Step 2, you have to remove all the self loop and write down whatever the diagram you have, same you have to write here. Clear? Next, in the third step, after removing the self loop, step 3, you have to remove a directed arrows because of transitivity. In the sense, for example, except reflexive term, in the sense 2, 2 is repeated, it is reference to reflexive, so you leave reflexive terms. Apart from that, if I have like 2 to 6 I have, fine, again 6 to 6 I have repeated elements, so I have to remove 2 to 6 arrow. So just for your reference, I will be explaining in detail only for this problem. See here, I'll just make a note of relation again by leaving the repeated terms. So what you're going to get is 2 to 6, 2 to 12, 2 to 24, 2 to 36, again 3 to 3 I'm going to leave, 3 to 6, 3 to 12, 3 to 24, 3 to 36. Again 6 6 I am going to leave, so 6 to 12, 6 to 24, 6 to 36. Again 12 12 I am going to leave, you are going to get 12 to 24, so 12 to 36, 24 24, 36 36 I am going to leave. Why? Because those elements are with reference to reflexivity. Fine. Now I have to check for the transitivity. I have to remove the directed arrows because of transitivity. Now take this element, first element, fine, 2 6. Next check for the element which has 6, which is starting with 6. See here it is 6 12. So I am going to remove 2 to 12. Fine. I am going to list here 2 to 12 arrow I have to remove. Fine. Similarly, this with this element, I am going to remove 2 to 24. Fine. Again, this with this element, I am going to remove 2 to 36. Fine. So, apart from this, there is no cases. Let me take second element. So, 2 to 12. So, when I am going to take 2 to 12, the element repeating is 12 to 24. So, I can remove 2 to 24, which is already removed. Next, 2 to 12, I have to remove 2 to 36. I have already removed. Clear? So this is also cleared. Now 2 to 24. I have to check for the element which starts with 24. Do we have any element which starts with 24? We don't have. So nothing to deal with this. Next 2 to 36. Do we have any element starting with 36? We don't have. So nothing to do with this. Next 3 to 6. Yes, I have. 6 to 12. So 6 6 get cancelled. I'll get 3 to 12 arrow I have to remove. These arrows I have to remove. Fine. So 3 to 12 I am going to remove. Next 3 to 24 I am going to remove again. Next this with this 6 6 repeated, so 3 to 36 I have to remove. Clear? Next, so anything else? No. Next 3 to 12, do we have an element? Yes, we have. See here 3 to 12, so 12 12 cancel, 3 to 24 I have to remove, which is already removed. Next 3 to 12, 12 to 36, so to 12 12 get cancelled, 3 to 36 I have to remove, I have already removed, so nothing is there. Next 3 to 24, anyhow we don't have an element starting with 24, so nothing to deal with this. 3 to 36, similarly 36 is also not there. I mean beginning element 36 should be there, but here it is not the case, so nothing to do with this. Next 6 to 12 I have, so 12 to 24 I have, 12 12 get cancelled, 6 to 24 I have to remove, 6 to 24. Fine. Next 6 to 12, 12 to 36, 12 12 get cancelled, 6 to 36 I have to remove, 6 to 36. Fine, nothing else. Next 6 to 24, no element starting with 24, nothing to deal with this. Next 6 to 36, no element starting with 36, nothing to deal with. 12 to 24, again no element with 24. 12 to 36, again no element with starting with 36. Now I have to remove all these directed transitive edges. This is what the third step is. So directed arrows because of transitivity we have to remove. Fine. Now let me do that. Here you may get a bit confusion, but you have to observe carefully. If you want, you can slow down the speed of this video and observe carefully. See here, this is what I have to remove, right? First let me remove 2 to 12 arrow which is directing from 2 to 12. I am going to remove 2 to 12. See here, 2 to 12. I am going to remove 2 to 12. So I have done this. Fine. Next 2 to 24. 2 is here, so 2 to 24 is connected. I have to remove that arrow also. Fine, I have removed. Next I have to remove 2 to 36. I have connected 2 to 36, so I am going to remove that also. Fine, I have done. So only arrow which is left with 2 is from 2 to 6. Fine. Next I have removed all the first 3 arrows. Next I have to remove 3 to 12. See here, 3 is connected to 12. I am going to remove that arrow. So 3 to 12 has been removed. Just for your understanding, I am going to do all this, but you have to do directly. As you practice so much of problems, you are going to get an idea. So 3 to 12 I have removed. Next I have to remove 3 to 24. See here, I have connected 3 to 24. Look at the direction here. 3 to 24 I have connected, so I have to remove that also. So 3 to 24. Fine, I have removed 3 to 24. Next 3 to 24 removed. Next 3 to 36 I have to remove. 3 to 36 which is connected, so let me remove 3 to 36. Fine, I have done. 3 to 36 also removed. Next I have to remove 6 to 24. See here, 6 is connected to 24. See here, 6 is connected to 24. I am going to remove that also. Fine, now you left with, let me dark this one and this one also, directed arrows. So this is what I have. Next I have to remove 6 to 24. So I have already removed that 6 to 24, right? Now 6 to 36. 6 to 36 arrow is there. Let me remove. So finally this is the hash diagram we have. Fine. See here. Fine. Step 3 is removing all the directed edges, that is due to transitivity. Step 4 is remove all the arrows. Remove all the arrows. So whatever the arrow direction is there, you just remove the arrows. Or else I can rewrite this exact diagram as, see here, 3 and 2 is not connected. So 2, 3 is not connected. Fine. 3 is connected to 6. 3 is connected to 6 and 2 is also connected to 6. So both are connected. 6 is connected to 12. 6 is connected to 12. Now 12 is connected to 36. 12 is connected to 36 and 12 is connected to 24. 12 is connected to 24. So this is the required hash diagram of this given particular relation. Clear? I am just repeating once again, and remember in hash diagram the relation will be from this direction below to or else I can say down to upward direction. So 2 is connected to 6, meaning is 2 is connected to 6, but 6 cannot connect 2. See here, do we have an element 6 and 2? We don't have. Again 3 is connected to 6, but 6 cannot connect 3. Clear? Again 12 cannot connect 6, but 6 is connected to 12. 12 is connected to 36. 12 is connected to 24. Reverse is not possible. So this is the required hash diagram. First step, rewrite the digraph representation of the given relation. Second step, remove whatever the self loops is there, you just remove it. Third step, make a list of transitive elements that I have already explained now. So remove all those transitive directed edges, so you will get a diagram like this. I can rewrite the given diagram in this way. Hope so it is clear. Let me explain one more example so that you will understand very well, and it is a very important problem, that is D30. So in the previous class I have explained the meaning of D30. It includes, D30 meaning is it contains divisors of 30 and a relation based on that. So let me see the next problem. So in your examination, question will be like, draw the hash diagram for D30, 1. So you have to write the rest of the relation also you have to write. So first you have to know divisors of 30, and it is given by 1, 2, 3, 5, 6, 10, 15, 30. I have explained this in previous video. Please go through that. So 2 divides 30, 3 divides 30, but 4 cannot divide 30. So likewise, I have listed all the divisors of 30. Apart from this, we don't have any divisors for 30. Now we have to write the relation D30, 1. I mean divisible. So I have to write the relation in such a way that when you're going to write an ordered pair, it should completely divide. So 1 divides 1. Similarly, 1 divides 2. I have already explained this. 1 divides all the elements in the given set. So I can write 1 divides 6, 1 divides 10, and 1 divides 15, 1 divides 30. Fine, next let me take 2. So if you're going to write 2 here, 2, 1, 2 cannot divide 1. Fine, but 2 divides 2. I can write 2. So 2 cannot divide 3, but 2 cannot divide 5, but 2 divides 6. So likewise, let me list all the divisors, all the ordered pairs. So you're going to get 3, 6, 3, 15. If you have any doubts, you can free to ask me. 5, 5, 5 divides 10, 5 divides 15, 5 divides 30. Similarly, 6 divides 6, 6 divides 30, 10 divides 10, 10 divides 30, and again 15 divides 15, and again 15 divides 30, 30 divides 30. So apart from that, you are not going to get any ordered pair in this relation. So you have to remember this. It is quite simple. If you just remember the divisors, or else no need to remember also, you just go through the order of numbers and check whether it is divisible by 30 or not. So you can easily note down the relation. Now I have obtained a relation. Now start with the hash diagram. As I already told you, step 1 is we have to draw the digraph representation. So let me draw the digraph representation. Elements I have to list from below, bottom. So 1, 2, 3, 5, 6, 10, 15, 30. Right? Now let me keep on giving the relation. 1 has been connected to 1. Next 1 is connected to 2. Arrow mark is important. Next 1 is connected to 3. Next 1 is connected to 5. 1 is connected to 6. Next 1 is connected to 10, 15, 30. 1 is connected to 10. 1 is connected to 15. 1 is connected to 30. Fine. Next 2 is connected to 2, self loop. Next 2 is connected to 6. Next 2 to 10. Next 2 to 30. Next 3 to 3. 3 to 6. Next 3 to 15. Next 3 to 30. Next 5 to 5. Next 5 to 10. Next 5 to 15. Next 5 to 30. The diagram looks a bit complicated, but you have to do it carefully. So 6 to 6. Next 6 to 30. Next 10 to 10. Next 10 to 30. I'm sorry, I cannot draw direct arrow, right? So 10 to 30, let me draw 10 to 30. Next 15 to 15. Next 15 to 30. 30 to 30. So this is the required hash diagram. It is looking just complicated, but you have to make it simple. So let me do that. Now as per the diagram, first step, remove all the self loop. So remove all the self loop and rewrite the diagram once again. So let me remove self loops. So whatever the self loop is there, I have just removed it. Fine. This is what the diagram we obtained in second step. Fine. Now second step, remove all. Step 2, remove all. Step 1 is drawing this. Step 2 is remove all reflexive. what we say, a self loop, right? And the step 3 is remove all transitive edges. Now you have to make a list of transitivity. You just do it separately, or else here itself you can do. See here, apart from what we say, reflexive identity, reflexive pair, make a list of all the elements once again. See here, 1 2 1 3 1 5 1 6 1 6 1 10 1 15 and 1 30. Next 2 2 you are going to leave, 2 6. Next 3 3 I am going to leave, 3 6 3 15 3 30. Next 5 5 leave it, 5 10 5 15 5 30. 6 6 I am going to leave, 6 30 10 10 I am going to leave, 10 30 15 15 leave it, 15 30 10 13 30 leave it. Now make a list of transitive edges. See here, 1 to 2 I have, so 2 2 get cancelled, 1 to 6 I have to remove. Fine, so I have to remove, let me write here, 1 to 6 I have to remove. Next 2 2 cancels, 1 to 10 I have to remove. Next 2 2 get cancels, 1 to 30 I have to remove. Fine, that's all. Next 1 to 3 I am going to take, I have to remove. 3 3 get cancels, 1 to 6 I have to remove, I have already done that. So 1 to 3 I have, again 3 to 15, 3 3 get cancelled, 1 to 15 I have to remove. Fine, again 1 to 3 I have, 3 to 10 I have, 3 3 get cancels, 1 to 30 I have to remove, I have already done that. Fine, now 1 to 5 I have, starting with 5, so 5 5 get cancels, 1 to 10 I have remove, it is already done. Again 1 to 5 I have, 5 5 get cancelled, 1 to 15 I have to remove, which is already done. Again 1 to 5, 5 5 get cancels, 1 to 30 I have to remove, I have already done it. So completes. 1 to 6 I have, so start with an element 6, we don't have, yes we have, see here, 6 6 get cancelled, so 1 to 30 I have to remove, which is already done. Fine, so nothing to do with this. Next 1 to 10, and do we have, yes 10, so 10 10 get cancels, 1 to 30 get, we have already removed, so nothing to do with this. Next 1 to 15, so 15 is there, so 15 15 get cancels, 1 to 30 I have to remove, I have already done that. Next 1 to 30, we don't have an element starting with 30, so nothing to do with this, it is also finished. Next 2 to 6, again I have 6 6 6 get cancels, so 2 to 30 I have to remove. Fine, that's all. Next 2 to 10, 10 10 get cancels, 2 to 30 I have to remove, which is already done. Fine, next 2 to 30, we don't have an element starting with 30, so nothing to do with this. Next 3 to 6, 6 6 get cancelled, 3 to 30 I have to remove. Apart from that, nothing else. Next 3 to 15, again 15 15 get cancelled, 3 to 10 I have to remove, 3 to 15 15 15 get cancelled, 3 to 30 which is already done, nothing else. Next 3 to 30, 3 to 30 we don't have an element starting with 30, so nothing to do with that. Next 5 to 10, starting with 10, yes we have, 10 10 get cancelled, 5 to 30 I have to remove, so let me do that. That's all. So 5 to 15 I have, 15 15 get cancelled, 5 to 30 I have to remove, which is already done. Next 5 to 30, since we don't have an element starting with 30, so nothing to do with this. Next 6 to 30, again we don't have an element starting with 30. Next 10 to 30, we don't have an element. 15 to 30 also we don't have an element. Fine. Now I have to remove all these directed edges. So let me do that. This is for your reference. Clear? Now let me keep on removing the edges. So it is visible, right? See, hope so it is visible now. Now let me remove arrow from 1 to 6, 10, 30, 15. 6, 10, 30, 15 from 1 I am going to remove. 1 to 6 first, let me remove 1 to 6. You can clearly note 1 to 6 I have removed. Fine. Next 1 to 10 I have to remove. Where is 10? Here it is. So 1 to 10 I have to remove. So let me do that. So 1 to 10 I have removed. Clear? Next 1 to 30 I have to remove. 1 to 30 I have removed. Clear? Next 1 to 15 I have to remove. Let me do that. 1 to 15 also I have removed. Fine. Next 2 to 30 I have to remove. Where it is, 2 is here. 2 has been connected to 30 here. So 2, if you want you can slow down the video speed and you can look carefully so that you can understand very well. So 2 to 30 I have removed. Next I have to remove 3 to 30. Where it is, 3 is here. 3 is connected to 30. See this wire. This arrow I have removed. Fine. 3 to 30 is also removed. Next 5 to 30 I have to remove. 5 is here. So 5 to 30 I have removed. Now let me make sure that left arrow, whatever the left arrow is, let me draw it again. Self loop, no self loop we have. The thing I have removed this one only, so this arrow is there. Fine. So 3 has been connected to 6 also, which is all not removed. Fine. It looks somewhat clumsy, but you have to understand, you don't have any way. Now let me rewrite this diagram in particular. Now one, let me as I already told you, Hash diagram represent a relation right from bottom to top. So let me draw 1 here. Fine. I have drawn vertex 1 here. You can clearly note that 1 has been connected to 2, 3, 5. First let me finish first vertex. 1 is connected to 2, 3 and 5. Let me do that. 1 is connected to 2, 1 is connected to 3 and 1 is connected to 5. So the minute when I draw as diagram, it represents a relation from bottom to top. So 1 is connected to 5, but converse is not true. Meaning is 5 is not connected to 1. Only 1 is connected to 5, 1 is connected to 3, 1 is connected to 2. Now vertex 1 is finished. I am rewriting the diagram exactly but in a simplified manner. See here now 2. Coming to the vertex 2, 2 is connected to, see here, see the arrow diagram. 2 is connected to 10. Fine. 2 is connected to 10 and 2 is connected to 6 also. You can see here. Look at the arrow diagram, direction of pencil, you just see 2 is connected to 6 and 2 is connected to 10. So 2 is connected to 6 and 2 is connected to 10. Clear? Next go through vertex 3. 3, look at vertex 3. 3 is connected to, see the direction, 3 is connected to 6 and 3 is connected to 15. Nothing else. 3 is connected to 6 and 3 is connected to 15, which is already drawn. Why? Because we don't have an arrow from 3 to 1. Arrow is only from 1 to 3. We have already represented it. Only 3 is connected to 6 and 3 is connected to 15. So 3 is connected to 6 and 3 is connected to 15. 3 is connected to 15. Fine. Now let me go to the vertex 5. Now you can clearly see that vertex 5, look at the direction of arrow. Vertex 5 has been connected to 10. See here, vertex 5 has been connected to, you just draw by just looking at the video, you just keep a sheet with you and you try to solve this, then you understand clearly. So 5 is connected to 10, 5 is connected to 15. So 5, where it is, yeah, 5 is connected to 10 and 5 is connected to 15. So I have drawn this, 5 is connected to 10, 5 is connected to 15. Next go through vertex 6. So look at the arrow direction where it is connected. Only we have only one arrow here. See here, 6 is connected to only one arrow. See, 6 is connected to 30. So 6 is connected to 30. Clear? Next go through 10th vertex. Now you can see that 10 for the vertex 10, what are the arrow marks going through vertex 10? 10 has been connected to 30. 10 has been connected to 30. So let me join, 10 has been connected to 30. Fine. That's all, nothing else. 10 is not connected to any other vertex. 10 is only connected to 30. Next coming to the vertex 15. Fine. 15 is connected to 30. Clearly visible here. See here. 15 is connected to 30. That's all. See here. A simplified version of Hash diagram is this. So this is the Hash diagram for D30. So you just take color pencils. For the time being, I don't have color pencils with me, so that's why I have tried my level better to explain. You just keep a sheet of paper with you and try to solve together with me. See the video once or twice, you will understand very well. So this is very important question, D30 hash diagram. So this is the simplified form of D30 hash diagram. I'll send you few more example with solution. Please go through the solution. If you are finding, you just try yourself. If you have any doubt, you are free to ask me. If you want, I'll solve that problem and send you. Thank you. Continue in the next session.